Good morning, seventh graders. Today is going to be easy. We're doing probability of independent and dependent events. So you guys should y'all were kind of exposed to it before Christmas break when I accidentally added the wrong quizzes assignment, and I did like little mini lessons. So I feel like you guys will be able to do this real easy, and I expect good grades to begin the semester. Okay, there is one thing I want to touch on before we begin examples is what is the difference in independent and dependent events? So if you use any bit of common sense you may have, independent is standalone and dependent is dependent on somebody else. So a really good example would be I'm independent. I can stand alone and pay my own bills. But my daughters, Maddox and Maddie B, are dependent on me and my husband to pay their bills. Okay, so they're dependent. They depend on me. So basically, in probability, when you're talking about independent and dependent events, an independent event is going to be, it doesn't matter what happens. So it may be like the probability of rolling a 2 and then the probability of rolling a 4 on a number cube. It's not independent. Those are independent. They don't matter. The second roll does not matter what happened on the first roll. Now, a dependent event would be something like you have a deck of cards, 52 cards, and we pull out a card. What's the probability of it being, a black card? Well, that's half of 52, okay? And then the next, you do another pull, but you don't ever put the one you pull, the first pull. Okay, so now your probability is changing because you didn't replace that card. You pulled that card, you did not put it back in, okay? So there are those, that would be a dependent event. The second event depends on what happened the first time, okay? So I hope that didn't scare you because I promise you today is easy. Okay, guys, so as you can see, we have a little scenario set up. So this is 2 spinners that are spun. So we have this spinner right here with nothing but numbers. 1, 2, 3, 4, 5, 6, 7, 8. And then we have a second spinner that's A, B, A, C, A, B. Okay? So looking at this, these are going to be independent events because it doesn't matter what I spin on this one. It's not going to affect what I spin on this one, okay? So here's an example of independent events, okay? So the first one we have to find, and I'm going to work my problem out down here and then put the answer, is the probability of spinning a 4 and a C. So here's my spinner, and the probability, I've got to do my labels. Spinning 4, I'm going to do S4 for spinning 4 out of total outcomes possible, okay? And you could do, if you wanted to, you could do TPO, total possible outcomes, okay? So I have 8, if I look, 1, 2, 3, 4, 5, 6, 7, 8, I have 8 total outcomes, but I only have 1 4, okay? So that's 1 out of 8. So I have a 1 in 8 chance of spinning a 4. Now, the letter C, I come over here, spinning C out of total possible outcomes. There are 1, 2, 3, 4, 5, 6 total possible outcomes, and there's only 1 C on this spinner. So to figure this out, I'm going to do 1/8 times 1/6, and 1 times 1 is 1, and 8 times 6 is 48. So you have a 1 in 48 chance of spinning a 4 and then spinning a C, okay? So basically, this is theoretical. What theoretically should happen when you spin a spinner, you have after 48 chances of spinning, you should have spun a 1 and then a 4 and then a C, okay? So let's go to the next one. What is the probability of spinning an odd and then an A? Okay, so an odd number. So I'm going to do SO, spinning an odd out of total possible outcomes. Okay, so I have 8 total possible outcomes. That's the easiest. I can see that. And then an odd number. I have 1 is odd, 2, 3, 4 odds. And we know that 4/8 is equivalent to 1/2. And if you reduce before you multiply, you don't have to multiply at the end. Okay? I mean, you don't have to reduce at the end. Sorry, not multiply. I'm losing my mind. Okay, and then spinning an A. So spinning A out of total possible outcomes. Again, we know that there's 1, 2, 3, 4, 5, 6 outcomes. And let's see how many A's. 1, 2, 3. Okay, 3 out of 6 spins will get me an A, but that reduces to 1/2. And we know that 1/2 times 1/2 is equal to 1/4. So the probability of spinning an odd number and then spinning an A is a 1 in 4 chance, okay? All right, here comes a little trickier one. You know, I like to save the best ones for last. Okay, so spinning less than 5 and then spinning a B. So spinning less than 5. Oh, wait, yeah, less than 5. Let's just do, instead of doing all that confusing, spinning less than 5 over total possible outcomes. It didn't say 5 or less. It said less than 5. Okay, so we know there's 8 out here. So less than 5, not 5 or less. So we have 1, 2, 3, 4. We have 4. You have 4 chances to spin a number less than 5, and we know we just did it. That is equivalent to 1/2. The next one is spinning a B out of total possible outcomes. We know there are 6 total possible outcomes. And if I look at this, there's 2 B's right here, 2 B's, okay? So if I reduce that 1/3, so 1/2 times 1/3 is equivalent to 1/6. So you have a 1 in 6 chance of spinning a number less than 5 and then spinning a B. Okay, guys, if you have a question, you've got to raise your hand. Okay, so next up, we have some dependent events. The first event is dependent on what happens on the second event. Okay, so there's going to involve reducing or simplifying fractions, so you need to be able to do that, and you need to be able to cross-reduce. All right, this is going to make your life so much easier. All right, so let's look at the board and let's look at the scenario. The scenario is there are 10 yellow, 6 green, 9 orange, and 5 red cards in a stack of cards face down. Okay, now we're drawing 2 cards. We're not replacing it. Once we pull one out, we're not sticking it back in there. Okay, it is going to be replaced. Sorry, I thought something came up on my screen. All right, so the first one we're going to do is the probability of selecting 2 yellow cards. So we pull a card out, then we do not stick it back in. We keep it out. Okay. All right, so first thing we have to do is figure out how many total cards do we have. Okay, so total cards is what I need to figure out because that's my total possible outcomes, my TPO. So we have 10, 6, 9, and 5. All right, so 6 and 5 is 11, and 11 plus 19 is 20, and 20 plus 10 is 30. So we have 30 total possible outcomes, 30 cards. All right, so the first one is probability of 2 yellow. So this is how we do it. Probability of yellow over total possible outcomes. Okay, so I have 10 yellow cards. So I have the probability of, I have 10 chances to pick out a yellow out of 30 possible outcomes, okay? And we know that 10 over 30 is equivalent to 1/3, okay? It's very important that you reduce before you do this. It just makes it easier. So I have a 1 in 3 chance of pulling a yellow card out of a stack of 30. The next one, we're not putting that card back in. So now we only have 29 cards. So we're still looking for the probability of pulling a yellow of total possible outcomes, okay? So now my total possible outcomes are 29 cards. I have 29 cards there because I didn't put that one back in, okay? And the probability, now I don't have 10 yellow cards left. I have 9. Okay, now 9 over 29, that is not going to reduce. So I'm going to come over here, and I'm going to do 1/3 times 9 over 29. I see that this doesn't reduce, this doesn't reduce, that doesn't reduce, but 9 over 3 reduces. I can divide both of these by 3. 3 divided by 3 is 1, and 9 divided by 3 is 3. So 1 times 3 is 3, and 1 times 29 is 29. So you have a 3 out of 29 chance of pulling 2 yellow cards without putting it back in, okay? So I hope that this is kind of easy. So what I want you to do now is I want you to try to do this next one. Pause it. The probability of 2 cards not orange. 2 cards not orange. Just pause the video, try your best, okay? All right, so assuming you paused and tried. Not orange over total possible outcomes. We have 30 total possible outcomes and 9 oranges. And I know this can reduce. I can divide both of these by 3 and reduce it or simplify it, whatever you want to say. 9 divided by 3 is 3, and 30 divided by 3 is 10. Okay, that doesn't reduce. All right, so, oh, I'm sorry, not orange. Sorry, hold on. I was doing orange, not orange. Okay, 30 possible outcomes. Okay, so we have green and red, 5 green, 6 and 5 is 11, and 11 plus 10 is 21. Okay, so we have a 21 out of 30% chance of pulling a not yellow card on our first attempt. I mean, not orange card, first attempt. I can see that this will reduce by 3. Okay, 21 will go into 3 7 times, and 30 divided by 3 is 10. That is as reduced as it'll get. Now, I did not put not orange, total possible outcomes. Okay, so I did not put the card back in. I didn't replace it. So now I have 29 cards to pick from, and there's 21. So now there's 20 cards that are not orange because I've already pulled out a not orange one. Okay, this can't reduce. So I'm going to come over here, and I've got 7/10 times 20 over 29. Now, this does reduce. I can cross reduce. 10 will go into 20 2 times, and 10 will go into 10 1 time. So now you're doing 7 times 2, which is 14, and then 1 times 29, which is 29. So you have a 14 out of 29 chance of pulling 2 cards that are not orange, okay? So hopefully you guys are getting this. Now definitely try this one, red, and then pulling an orange. Pulling a red, then pulling an orange, but you're not putting that card back in, okay? Okay, so probability of red out of total possible outcomes. Okay, so I have 30 total possible outcomes. It's important that you do the order that they say first, red, then yellow. Okay, so I have 5 red cards. 5 out of a 30, I always want to say percent chance, 5 out of 30 chance of pulling that. So I'm going to reduce this. These will both divide by 5. 5 divided by 5 is 1. 30 divided by 5 is 6. So you have a 1 in 6 chance of pulling a red. Now, we didn't put that card back in. And now we're looking to know the probability of orange over total possible outcomes. Okay, so we have 29 total possible outcomes now, and we have 9 orange, right? 9 orange. Okay, so now we need to multiply 1/6 times 9 over 29. Now, I can cross reduce these two. I can divide them both by 3. That'll be 2. And then this will be 3, which is 1 times 3 is 3. And then 29 times 2, I'm just going to add it, 58. 3 out of 58 chance. So I hope that you guys are understanding this. This is the last lesson in chapter 5. Tomorrow we will review, and then Friday you will test. And I hope you guys had a wonderful Christmas break. I missed you all.